Okay, so these questions are going to be what the questions look like, but we're just doing the first 3 steps, and then we're looking at what's happening in the problem. And I think this will help clear up some of what we're going to do in next time. So for example, in example 1, we're given the drug Lipitor is meant to reduce cholesterol and LDL cholesterol. So in clinical trials, 19 out of 863 patients taking Lipitor daily complained of flu-like symptoms. Suppose that it's known that 1.9% of all patients taking competing drugs experience flu-like symptoms. Determine if there's sufficient evidence to conclude that more than 1.9% of Lipitor users experience flu-like symptoms as a side effect at the alpha is 0.01 level of significance. So first, how do we know that it's a hypothesis test if we have a bunch of questions together? So it says things like determine if there's sufficient evidence, and it's looking at a level of significance. So that tells you it's a hypothesis test. Is it a mean or a proportion? If you look in the question, it never says the word mean. And it has to say it if it's a mean question. So we're looking at a proportion or a percent question. So that'll be our first step, mean or proportion. So we'll pick, in this case, proportion. So second, what are the null and alternative hypotheses, and what is the level of significance? The level of significance is easy, it's right here, so it's 0.01. Now we know that it's about a proportion, so our hypothesis tests are going to be about P. P is our proportion in the population. So we're told that it's known, here's our clue, it is known that 1.9% of all patients experience flu-like symptoms. So our P is going to be 1.9%, and we're going to write 1.9% as a decimal, 0.019. So that's going to be the same number in the alternative hypothesis. So now we have to think, is it a less than or a greater than or a not equal here? They ask, is there sufficient evidence to conclude that more than 1.9%? So that means it's a greater than. So that's my null and alternative hypotheses. Are there any questions on that one? Okay. Step 3 is to find my sample mean, my sample standard deviation, and my sample size. So my sample mean and standard deviation and size is all right here. Oh, sorry, not sample mean. We're using proportion, so you only have to fill out this side, the proportion size. So all you need is our X and our sample size. Remember, this is the number of success and our sample size N. So it was 19 out of 863. So our X is 19 and our N is 863. Okay, so that's going to give us a p hat of 19 over 863. Which is 0.022. Okay, so typically you're going to go on to step 4 at this point when we do it next time. But I want to do is actually draw a little sketch of what's happening, label the mean, the sample statistic, and shade in the p-value. So I'm going to go on the side here so I don't have to get rid of everything. So here is our mean, our mu sub p hat, which is equal to p, and that's 0.019. So the number that appears here is the mean of our distribution. Our p hat is 0.022. So our p hat is going to be over here, and it's slightly bigger, 0.022. And this shaded area to the right, this is our p-value. So that's where I want you to stop, except for the one part that says the probability that our p hat is greater than or equal to 0.022 is going to be equal to our p-value. And we want that to be less than 0.01, our alpha. There are no questions? Anything you want me to go over again on that one? Do you know where I got everything? Okay. No questions. I'll go on to the second question.
I have a question.
Yes.
So when you say to write the probability statement, we're always going to write it like you showed in the first example?
Yes.
Okay.
We're going to go through 6 examples, and it's going to start clicking a little bit as we go through more examples.
Okay.
So let's look at the next question, example 2. In 2001, the mean rate of inmates on death row was 40.7 years, according to data by the U.S. Department of Justice. A sociologist wondered if the mean age has decreased since then. She randomly selects 32 inmates who have a mean age of 38.9 and a standard deviation of 9.6, tests the claim at the alpha equals 0.05 level of significance. So again, we're asked to test the claim. That tells us hypothesis test. We're given an alpha equals 0.05 level. But the question is this a mean or a proportion? We have the word mean. We don't have any percents in the problem, so it's a mean question. Our alpha is 0.05. And the question is, what are the null and alternative hypotheses? So she wonders if the mean age has decreased since they recorded 40.7 years. So the original mean was 40.7, but she believes it's now less than 40.7. So our null hypothesis is that the mean rate was 40.7 and hasn't changed. Her hypothesis is that the mean is now less than 40.7. So we're doing a mean, and we don't need the proportion side of this chart. Now we look for our sample data. Our sample is 32 inmates. That's our sample size. A mean age of 38.9. And a standard deviation of 9.6. So this part is all about the sample data. Okay. So what's happening in this problem? That's where we draw the sketch and do the probability statement. So the sketch is, here's our mean sub x bar, which is 40.7. Our data is 38.9. So that's our x bar. And the shaded area is the p-value. So we want the probability that x bar is less than or equal to 38.9, and that's our p-value. And we want that to be less than or equal to alpha, which we were given is 0.05. Any questions in this? Nothing? Okay. I will take a picture. We'll go on to number 3. A bank claims that the mean waiting time in line is less than 1.9 minutes. A random sample of 20 customers has a mean of 1.7 minutes with a standard deviation of 0.8 minute. Is alpha is 0.05, test the bank's claim. So what type of test is this? We have a mean because it says mean. The null and alternative is looking at the waiting time is less than 1.9 minutes. So the claim is that the mean is less than 1.9 minutes. So we have a mean of 1.9 minutes as our null hypothesis. And we're given alpha is 0.05. Our sample data is for the mean. Sample mean was 1.7. Sample standard deviation 0.8. Sample size 20. So again, our distribution. Here's our mu sub x bar, and that's equal to 1.9. And our data, x bar is 1.7. And this shaded area is our p-value. So the probability that x bar is less than or equal to 1.7 is equal to our p-value, which we would like to be less than or equal to alpha, which is 0.05. Okay, seeing no questions. Halfway there.